1 plus y.
1 plus
1 plus y.
No, your u is correct, 1 minus 2x. Your v is not quite correct. Anyone else with a different v?
I have 1 minus y.
You guys, you're making silly mistakes. Nitawapiga mangumi. Any other person? Wait, what was your original function f of z? Maybe I could have made a mistake. I don't know. Let me just scroll up. Do you have 1 plus I minus z bar?
Yes.
So 1 plus I minus z bar. What is z bar? But remember, you have a minus. Or am I the one having the wrong u and v? So our f of z is 1 plus I minus z bar. But z is x plus iy if and only if z bar is x minus iy. So 1 plus I minus z bar is 1 plus I minus in brackets x minus iy. Oh yeah, I see. It's supposed to be 1 plus I minus 2z bar. Minus 2z. One plus I minus 2z bar. F of z is 1 plus I minus 2 times z bar, 1 plus I minus 2 times x minus iy, 1 plus I minus 2x plus 2iy. To collect together the real parts. One minus 2x plus I into 1 plus 2y, so that your u is 1 minus 2x, v is 1 plus 2y. If we apply the formula for integration or contour in evaluating contour integrals, 1 plus I minus 2z bar dz, the formula is u dx minus v dy. So we'll have, we are integrating the line integral 1 minus 2x dx minus, we integrate this 1 plus 2y dy plus an I times, it affects some two integrals here, 1 plus 2y dx plus, we're integrating 1 minus 2x dy. So we go to part A. Part A, we are talking of the straight line connecting Z1 and Z2. So you need to sketch your Z1, Z2. Our Z1 is 0, so our Z1 is here. Z2 is 1 plus I. Our Z2 is here, 1 plus I. So we're only given points. Z1 is 0, Z2 is 1 plus I. So in other words, we have the points 0, 0 and 1, 1. We need to come up with the equation of the straight line connecting these 2 points. So we first compute the gradient, change in y over change in x. 1 minus 0 over 1 minus 0, it's just equal to 1. Next, we need the equation. So we pick the gradient which is 1. We can pick the point 0, 0 together with x, y, then come up with the equation. Change in y minus 0 over x minus 0 should give us the gradient, which is 1. Y over x is equal to 1, or simply y is equal to x. So you can arrive at this by, computing the gradient, then calculating the equation of that straight line, or from your sketch, you could easily see that this corresponds to the line y is equal to x. If we had it on this other side, then we'd have y equals minus x, and so on. So we have the equation of the straight line connecting z1 and z2. The equation is y equals x. So using this, we either want to convert everything in terms of x or in terms of y. So either way should work, because from y equals x, dy is equal to dx. So you can either choose to express everything in terms of x, so that you're dealing with the x values. Actually, for this particular problem, everything is varying between 0 and 1. So whichever way you do it should be okay. So we can use values of x between 0 and 1. In place of y, we substitute with x. In place of dy, we substitute with dx. And then evaluate that integral C and check what it would give us. So putting x, so we'll have the line integral from 0 to 1. 1 plus 2x dx. Our u is 1 minus 2x, starting from 1 minus 2x, so 1 minus 2x dx, minus v dy, we're integrating from 0 to 1. Our v is 1 plus 2x, but x is equal to y, so 1 plus 2x dx, plus an I times 1, we're integrating from 0 to 1, 1 plus 2x dx, plus we evaluate from 0 to 1, 1 minus 2x, in place of dy, we replace with the dx. Integrate 1 minus 2x, you should get x minus 2x squared divided by 2, so it's just x minus x squared. Minus, when you integrate 1 plus 2x, you get x plus 2x squared divided by 2, so that is x plus x squared, plus an I into, integrate 1 plus 2x with respect to x, you get x plus x squared. Integrate 1 minus 2x, you get x minus x squared. Everything runs from 0 to 1. So this is from 0 to 1. They can do this. So we will have 1 minus 1 squared minus, in brackets, 1 plus 1 squared plus I into 1 plus 1 squared plus 1 minus 1 squared. 1 minus 1 squared is 0, minus, into brackets, 1 plus 1 squared is minus 2. So minus 2 plus I times 3 minus 1 is 2. So you get minus 2 plus 2i. I'm not sure about other questions, but this one will be there in the exam. I'm a nice person. I'm the best thing that happened to engineers. The anomalous expansion of water has to happen, But any 40 out of 30 should be too easy. Part B. we are having the parabola y equals x squared. You only need an equation of the circle. Are you having a straight line? I mean, we're looking for C. Are you having a straight line? Have you been given coordinates, or have you been given the equation? If you're given the equation, you don't need to do any computations. You just go straight to the equation, check how you can write everything in terms of x or y, then proceed. So if we are given a parabola, you are given y is equal to x squared. So you already have what to work with. Using this equation, you either want to transform the integral so that everything is in terms of x or y. So if you were to write everything in terms of x, then making this the subject, you have x squared equals y, so you would have x equals square root of y. So replace x with square root of y, but this doesn't really look nice. It would be easier to express y in terms of x. So go, whenever you see a y, replace with x squared. So once you choose the appropriate variable, then you need to evaluate the appropriate differential. Differential, sorry. So y, we will use y equals x squared. So dy will be equal to differentiate x squared, you get 2x dx. So in place of y, you replace with x squared. In place of dy, replace with 2x dx. Then since you're converting everything to x, you use the limit of integration for x, and clearly x lies between 0 and 1. So you go back to your equation. So you say that contra integral, integrating from 0 to 1, 1 minus 2x dx. Minus, integrating from 0 to 1, 1 plus 2y but y is x squared. Just unmute and speak up. Y is x squared, so 2 times y is 2 times x squared. Then dy is 2x dx. Be careful. I hope I'm not too fast. Plus I into, here we have, what do we have? What do we have here? Maybe I should have left this as an exercise. I can leave it there, Cindy.
We'll have 1 plus 2x squared
1 plus 2x
Yes.
squared dx plus
plus 1 minus
1 minus
2x squared.
what do we have here? Is it u or v? Is it supposed to be u or v? Originally, do we have, from the formula, what is the formula?
The formula is v dx plus u dy.
U dy. What is our u? One minus 2x, right?
Yes.
Our dy is
2x dx.
2x dx. If you simplify this, what do you get? should be able to get x minus 2x squared minus x power 4 from 0 to 1 plus I into x minus 2 over 3x cubed plus x squared from 0 to 1. Should be easy to see. So you get, to simplify this, you should get negative 2 plus 4 over 3i. For part C, on the segment Z1, Z2, I think you can do that as an exercise. So you finish the computation for part C.
Excuse, would you scroll up? Okay.
You guys done copying the exercise. Are we at par?
Kindly scroll upwards.
Yeah, just show up for a physical class. If you die, you die. If they beat me, they beat me. See. But when it was my turn to fight for their rights, I showed up. We talked to the president. We told him about there being a conundrum, pandemonium, focus and fracas. Now it's their turn, but yeah, let's see.
Scroll up a little bit more.
To what exact point?
Part A.
Part
A of the question.
Oh, you do part C of the above problem. The question, you had already written it. It had 3 parts. There was part A, part B. Part A was the straight line from 0 to 1 plus I. Part B was the parabola, which we just concluded. Then part C was the broken Z1, Z2, Z3, where Z3 equals 1. We had written it at the start of, that particular problem. So this integral simply means, let me see. Evaluate this integral from 0, 1 to 2, 5. It's just a straight line. Do a sketch from the point 0, 1 to 2, 5. So the x values are between 0 and 1, 0 and 2. The y values are between 1 and 5. But you will decide what to use accordingly because you are guided. You're given the appropriate curves. But A, you're given the curve as y equals x squared plus 1. So if you choose to write everything in terms of x, then it means whenever you see a y, you replace with x squared plus 1. Dx will be dy will be 2x dx and so on. Part 2 is the straight line from 0, 1 to 2, 5, and then from 0, 5 to 2, 5, you do that sketch. Then do the integration in bits. Start from 0, 1 to 2, 5, obtain the appropriate equation of the straight line connecting those 2 points. As well as for the second part, there's no rocket science. So special cases. If the integral is assigned D, then you have does not depend on the path. You'll see this once you finish part C of the other problem on the path of integration. In this case, so for contour integration, it doesn't always have to be a C. It can be any index. It can be L. It could be gamma. I believe those who have come across past papers will see questions like evaluate the following integral around, and you'll see symbols like, so they will have a symbol like this. I told you that is small gamma or this capital gamma. And then they will specify what gamma is. They can tell you gamma, where gamma is a square whose vertices are the following, or gamma is a rectangle, or gamma is a parabola or a straight line. So if you see gamma, don't say the lecturer did not teach. Hatukufunzwa hilo. It's a dummy index. Where L is any piecewise smooth closed curve in D if a curve is specified parametrically, if curve C is given parametrically, i.e. where both x and y are given in terms of t, so where x is a function of t, y is also a function of t, and the beginning and end of curve C corresponds to t equals t naught and t equals t1 respectively. This is not good, I need to do this. Yeah.
Could you please scroll up to part A?
Part A, okay.
A bit lower where XZ is.
Is that okay?
Yes.
Let me know when you're done.
Done.
Then if x and y are given parametrically, then you'll have to convert everything to t. You'll have to convert your function f of z. So you'll evaluate from t naught to t f of z times z prime of t dt. Where z of t is x of t plus I y of t. Let's give an example to illustrate this. should be able to stop after this example. Evaluate this integral from 1 minus I to 2 plus I. The function is 2x plus iy plus 1 dz. Evaluate from 1 minus I to 2 plus I, 2x plus iy plus 1 dz along x is given as t plus 1, y is given as 2t squared minus 1. Now I can actually add more assignments. So I can say this is part A, then there will be a part B where you'll go and do that. So part A, you have the parametric equations. Part B is just what we've done previously, straight line joining 1 minus I and 2 plus I. So we go through part A and then we should be able to stop. So if you're given an equation parametrically, then your function is given, your function f of z is given in terms of the variables x and y, but those variables are functions of the parameter t. So you only need to go back to your function. Our f of z is 2x plus iy plus 1. dz is obviously, if z is x plus iy, then dz is dx plus I dy. So in place of dz, we will have dx plus I dy. But we need to convert our z from x and y to variables, to a function of the variable t. How to do that? We're given the parameterization of x and t and y as x equals t plus 1, y equals 2t squared minus 1. So we want f of z dz, but it should be given in terms of the parameter t. Let's first convert our f of z. Or maybe from here we can get our dx and dy. Then proceed to convert our f of z. So if x is t plus 1, what is our dx?
dt.
Dx is dt. What is our dy?
40 dt.
40 dt. So what will be our dz? We can actually finish with that first before we go back to f of z. What is dz?
dt plus I 40 dt.
40 dt. So that will be our dz. We have dz in terms of the variable t. We need our f of z in terms of the variable t. F of z is 2x plus iy plus 1. But our x is t plus 1, our y is 2t squared minus 1. So this is 2 times our x is t plus 1 plus I times our y is 2t squared minus 1 plus 1. 2 times t plus 1, this gives us 2t plus 2 into 2t squared minus 1 plus 1. We can group together 2 and 1. These two are like terms. 2 plus 1 is 3, so we'll have 2t plus 3 plus I into 2t squared minus 1. So our f of z in terms of the variable t, or simply f of t, is 2t plus 3 plus I into 2t squared minus 1. So this integral, no, we need the limits of t because we're converting everything into the variable t and then perform the integration. What are the limits of t? X is t plus 1 implies t could be x minus 1. But our x are from 1 minus 1 to 2, 1. These are the limits given originally. X is changing from 1 to 2, y is changing from minus 1 to 1. So using x equals t plus 1, t is x minus 1. So when x is equal to 1, t will be 1 minus 1, and that is equal to 0. When x is equal to, x is changing from 1 to 2. So when x is equal to 2, t will be equal to x minus 1. X is 2 in this case, 2 minus 1. 2 minus 1 is 1. So the limits of t are 0 to 1. If you use y, you should be able to get the same limits. Y is 2t squared minus 1. Y is changing between minus 1 and 1. When y equals negative 1, then we have minus 1 is equal to 2t squared minus 1, or minus 1 plus 1 equals 2t squared. 0 equals 2t squared. T is equal to 0, the first limit. When y is 1, 1 equals 2t squared minus 1. Bring 1 to this side. 1 plus 1 equals 2t squared. 2 equals 2t squared. Divide by 2t squared equals 1. T is square root of 1. So you get 0 and 1. In other words, t will run from 0 to 1. So our integral from 1 minus I, 2 plus I, 2x plus iy plus 1 dz will become the integral from 0 to 1. Our f of t is 2t plus 3 plus I into 2t squared minus 1 times dz, but dz in terms of t is 1. Okay, it's dt plus 4i dt. dt plus 4i dt. If we factor out dt, it's the same thing as 1 plus 4i. Then we have a dt outside. So this is the integral from 0 to 1, 2t plus 3 plus I into 2t squared minus 1 times 1 plus 4i dt. We can actually expand this product. So this is the integral from 0 to 1. So the whole of this times 1 is the same thing. So we'll have 2t plus 3 plus I into 2t squared minus 1 dt plus, we want to integrate again from 0 to 1. The whole of this product times 4i, then times dt. So 4i times 2t will give us 8ti. 4i times 3 gives us 12i. 4i times I into that product will have a 4i squared outside, but I squared is minus 1, so we have a minus 4. Minus 4 into 2t squared minus 1, then times dt. But we can actually expand that. So 0 to 1, 2t plus 3 plus I into 2t squared minus 1 dt plus 0 to 1, 8ti plus 12i So if we distribute then 4, the negative 4, we have minus 8t squared plus 4 everything we integrate with respect to the variable t. So if you integrate this, what do you get? Integrate 2t, you get 2t squared over 2. That is just 4, t squared. Maybe I should just write everything down. 2t squared over 2 plus 3t plus I times 2t cubed over 3 minus t plus 8t squared over 2I plus 12ti minus 8t cubed over 3 plus 4t. 2t squared over 2 is just t squared, so this is t squared plus 3t plus I into 2t cubed over 3 minus t plus 8 over 2 is 4, 4t squared I plus 12ti minus 8 over 3t cubed plus 4t. We're evaluating the whole thing between 0 and 1. So we have 1 plus 3 plus I into 2 over 3 minus 1 plus 4I plus 12I minus 8 over 3 plus 4. What do you get? Or are we leaving out anything? Are we having the correct thing? It was our DZ. We must have left out something. Our DZ is dt plus 4it. There was a t somewhere. There is a t, so that affects the second part of the expansion. Here's our dz. Dz is dt plus 4it dt. So in place of dz, we're supposed to have dt plus 4it dt. So there is a t here. Wait. This is 4it. There's supposed to be a t here, 4it. There's supposed to be a t here. So that means when doing the expansion, the second part should have an extra t, 4it, not just 4I. So 4it times 2t plus 3 plus I into 2t squared minus 1, we should get 8t squared I. So this should be 8t squared I. I hope you're able to follow through and make the appropriate corrections. Plus 3 times 4it, so this is 12it minus 4t into that product. Let me just erase these. So this is, we're integrating from 0 to 1. The first part is okay, plus I into 2t squared minus 1 dt. For the second part, it's 0 to 1, 8t squared I plus 12it minus 4t times that product. So 8t, 4t times 2t squared is 8t cubed plus 4t dt. If you integrate that, what do you get? We need to stop. So you erase this. Is anyone following? Integrate 2t, you get 2t squared over 2t squared minus 3t plus I into 2t cubed over 3 minus t plus 8t cubed over 3 times I plus 12t squared over 2 times I minus 8t power 4 over 4 plus 4t squared over 2. If we evaluate this between 0 and 1, so you have 1, this was t squared plus 3, not minus. Just unmute and speak up. From 0 to 1. Two t plus 3 plus I into 2t squared minus 1 plus integral from 0 to 1, 8t squared I plus 12it minus 8t cubed plus 40. Integrate this, you should get 2t squared one plus plus